Greetings, my beloved scholars. I remain your online physicist teacher, Mr. Okafor PC. Our topic of discussion today is relative motion. Relative motion. Recall, motion involves change in position of a body with respect to time. Motion involves change in position of a body with respect to time. And the word relative brings about comparison. Here we'll compare two bodies in motion. Or we'll compare a body in motion or a body believed to be at rest. We'll also compare a body in motion or another body presumed to be at rest. Let me ask you, have you noticed this phenomenon in your day-to-day activity? When a passenger is inside the vehicle, and when the vehicle begins to move at uniform speed, and the passenger looks outside the vehicle to observe the environment, the passenger notices that electric poles or trees outside are moving, whereas the passenger presumes his or herself to be at rest. Have you noticed such phenomenon in our natural world setting, where a passenger that is moving with a vehicle presumes to be at rest, and the standing trees outside the vehicle are now presumed to be moving, or the electric poles or the bushes around begin to move, whereas it's the passenger that is moving. The passenger inside the vehicle sees the stationary trees or electric poles to be the bodies moving, and the passenger that is actually moving presumes he or she is at rest. This idea of relative motion. When human beings begin to imagine about the wonders of motion, then it is also dependent on their own, on the motion of their own medium. Because all of us are in a moving body, the earth is moving. So there's a kind of misconception that comes when we do comparison of motion. This is the target of relative motion, to clear that misconception. A good example is our ancestors believe that the earth is fixed and the sun revolves around the earth. Why? Our ancestors could see the sun rising from the east and setting at the west. So our ancestors believed that the earth wasn't moving, but the sun was moving. And they could see the sun shifting from east to west. Therefore, to them, the sun is revolving around the earth. But today, we've cleared that misconception, relative motion. Today, we now know that it is the earth that is actually moving around the world, sun, and not the sun moving around the earth. Comparison of bodies in motion. So we have to do careful analysis of bodies in motion to clear doubt. That is one of the targets of relative motion. So to clear this confusion of relative motion, there are 4 categories that you must be aware of in relative motion. You must be aware of these 4 categories, or let me say 4 confusions that you must clear in relative motion. The first condition, or the first category is when a body is moving and there is another body on the moving vehicle. There is a confusion that must be cleared there to understand relative motion. If a passenger, for instance, is inside the car and the car is moving, this is the first condition we're talking about, the first category. When the passenger is seated at a position and the car is moving or the vehicle is moving, that passenger has the same speed as the moving car. This is the first thing you must note in relative motion. If you are inside the moving car, seated, you are not moving, you are just inside the car, your speed is the same as the speed of the car. If the car is going at a speed of 20 meters per second, that is also your speed, provided you are seated in that vehicle or you're on the vehicle. That explains why you are shifting from one position to another position, because you are moving with the same speed with the vehicle. This is the first condition of the first category. A good example is the Mother Earth. Anytime humans are sleeping at night in the surface of the earth, they are moving at the same speed with the earth. The earth is not static. The earth is moving at uniform speed of 460 meters in 1 second. 460 meters per second. That's the speed of the earth. The earth rotates with speed of 460 meters per second. So anytime we are static, we are at a particular position in the earth, we are also going at that speed. We have the same speed as the Mother Earth, but we don't know. But that's what happens. That's the first condition in relative motion. The first thing we must clear. So a passenger at a particular position on a moving vehicle shares the same speed as the vehicle. Then the second condition, the second category is When the vehicle is moving and the passenger on the vehicle begins to move, there are two ways the passenger can move. It's either the passenger moves in the forward direction or the backward direction. When the passenger moves forward, let's say the passenger is seated at the back seat. The passenger is at the back seat and the vehicle is moving with speed of 20 meters per second. Then this passenger now stands up and begins to approach the driver with speed of 2 meters per second. In every 1 second, this passenger covers 2 meters towards the driver. Then the relative speed will change. This passenger is no more going at the speed of the vehicle. This passenger is now faster than the vehicle. How did it happen? The passenger now, in every 1 second, the car covers 20 meters. In that same 1 second, the passenger covered what? 2 meters. Therefore, the relative speed of this passenger now is now 20 plus 2, 22 meters per second. This passenger is now faster than the vehicle. Because in 1 second, the vehicle covered 20 meters. In that same 1 second, the passenger covered 2 meters. So this passenger is faster. Relative motion. We must clear every misconception here. So anytime you are moving on a vehicle, it's either you are going faster than the vehicle or you are reducing the speed of the vehicle. In the same direction with the vehicle, you are increasing your speed. You are faster than the vehicle. 20 plus 2 meters per second now becomes 22 meters per second. That's the speed of the passenger towards the driver. Then when this passenger wants to return back to his or her seats, and the passenger maintains 2 meters per second, this time the car is going forward, and this passenger is going backward, opposite direction, then this passenger will minus from the speed of the vehicle. It will now be 20 minus 2, giving us 18 meters per second. Okay, let's see from the board. This time the passenger is going this way and the vehicle is still going this way. 20 meters per second. And the passenger is now going back with 2 meters per second. So the relative speed becomes 18 meters per second. 20 minus 2 to give us 18 meters per second. So let me summarize the first two conditions. If a passenger is on a vehicle and the vehicle is going at speed of 10 meters per second and the passenger is seated on the vehicle, the speed of the passenger is also 10 meters per second. But if the vehicle happens to be going at 10 meters per second and the passenger stands up and begins to walk towards the driver in the same direction as the vehicle with speed of 3 meters per second, then the relative speed of the passenger with respect to the car becomes 13 meters per second, 10 plus 3. Then when this passenger goes back to his or her initial position, this time in opposite direction to the vehicle, movement of the vehicle will minus 10 minus 3. The relative speed becomes 7 meters per second. Very simple idea. These are the first two conditions where one body contains the other body. We now do the comparison. Then there are these other remaining two conditions where none of the bodies contain the other. They are separate. There are two distinct bodies moving on their own. A good example, when two vehicles leave a park, this is the third category. When two vehicles leave the park and one goes in the leftward direction and the other one in the rightward direction. This is the third scenario. Yeah, we have two vehicles on their own, none is containing the other. One picks an opposite direction to the other one. Let's see from the board. Okay, I think we've done justice to 1, justice to 2. Then let's go on to, we'll skip 3, we'll come to 4. When two bodies are moving in opposite directions, two vehicles leave from a park. One is going at speed of 20 meters per second. The other is going at 30 meters per second. We have one in opposite direction, 20 meters per second, the other 30 meters per second. Then the question becomes, in most external exams, you see this type of question. The question becomes, what is the relative speed of the two vehicles? A very simple answer. The answer is 30 plus 20, 50 meters per second. Why? A very simple idea. In 1 second, this car covered 20 meters. In the same 1 second, this car covered 30 meters. 1 second is just one. In just one tick of time, 1 second tick of time, this one covered 20 meters, that one covered 30 meters. Just in 1 second, 20, 30. In 1 second, both cars have covered 50 meters gap. Therefore, the relative speed there is 50 meters per second. No wonder when you look, you now see the car is far away. Because in 1 second, one covered 20. In the same 1 second, one covered 30. Altogether, in 1 second, they cover 50 meters per second speed. That explains why the cars are far away. They are faster. Relative speed. When two distinct moving bodies go in opposite direction, they add up. They add up. They cover bigger gap in a short time. Relative speed. Then the last one, which on the board is the third one? When two distinct moving bodies go in the same direction. This is what we see in Olympics. This is what we see in athletics. 100 meters race, 200 meters race, where you gather athletes and put on the same line. On your mass, get set, this is what we see in the same direction. In the same direction. Recall in opposite direction we added, but in the same direction we subtract. That's how we can tell who is faster. Okay, let's give example on the board. This time around, they are moving in the same direction. One athlete goes at 10 meters per second, another in 15 meters per second. In the same direction. The question becomes, what is their relative speed? That question is demanding for the faster athlete, and that is 15 minus 10, 5 meters per second. 5 meters per second. Relative speed of two distinct moving bodies in the same direction you minus. 15 minus 10, 5 meters per second. Okay, let me give you a clearer instance. Let's say your dad buys a new car. I'm giving an example. If your dad or my dad buys a new car, my dad tells me that this is the fastest car on earth. Yeah? I said, Dad, you mean it? Yeah, it's okay. Dad, let's confirm it. Let's have a ride on the way. Then your dad enters the car, you join your dad. Then my dad begins to flow on the way or begin to drive on the way. Then my dad passes the first car, second car, third car. I'll give my dad a thumbs up. Dad, this is the fastest car on earth. Then fifth car, sixth car. Then all of a sudden, the seventh car will come and pass my father's car. Whoop! I'll look at my dad looks at me. Then we'll continue. Eighth car will come again and pass us. Zoop! Ninth car, zoop! I'll look at my dad. Why my dad and myself looking back at my dad, why we're doing that is because something is happening. There is an experiment that is being carried on the way, and that experiment is relative speed. For any car to come and pass my daddy's car, that means that car is faster than my daddy's car. The first car did that, the second one and the third one did that. That means there are about 3 cars faster than my father's car. Therefore, my father's car is not the fastest car on the way. Because any car that will pass my father's car is passing my father with an additional speed. And to get that speed, I have to know the speed of that car, the speed of my daddy's car, then subtract and know the advantage that car has over my father's car. The car has advantage, speed advantage over my father's car. It's either my father's car is not the fastest car on the way, or my father has reduced his driving speed. These are the two conditions. It's either my father has lowered the driving speed, or the car is faster than my father's car. Okay, this is the idea of relative speed. In the same direction, minus, opposite direction, add. Yeah, it's speed, relative speed. When 2 cars move from a park and they go in opposite direction, to get the relative speed, we're adding. They move in opposite direction, so we add to know why they are far away. Then when athletes are running in the same direction, we minus to know who is faster. Yeah, very sharp idea. Just take time. Imagine on the IDX and see how simple it becomes. In summary, if a body is moving and it contains a passenger, the passenger shares the same speed as the moving body. When the passenger begins to move in the same direction with the vehicle, the passenger adds up the speed. When the passenger goes in opposite direction, the passenger subtracts from the speed of the vehicle. Then when 2 distinct bodies are moving on their own and they move in opposite direction, the relative speed says you must add. When they go in the same direction, it says you must do what? Subtract. My beloved scholars, I want to believe that the findings of relative motion is now at your domain. Please stay tuned on this platform and do subscribe.